Welcome to Through Inquisitive Kids. In this video, we will be talking about arithmetic progression. So let's say that I gave you the expression 1 plus 3 plus 5 plus 7 all the way up to 97 and 99. And I'm going to ask you to simplify this expression and find the value of it. And so how would you do this? So first pause the video and see if you can figure it out yourself. So there's actually two different ways to do this. The first way is a special method you could use for this particular sequence. Or the other way is the more general way that you would use to solve for any type of these questions. So this sequence is special because it starts from 1 and then it keeps adding all of the odd numbers. So let's first start off small and see if we can find a pattern. If we only have 1, the sum is 1. If we have 1 and 3, the sum is 4. If we have 1 plus 3 plus 5, the sum is 9. And if we have 1 plus 3 plus 5 plus 7, the sum is 16. So what can you notice? What pattern can you find out of these sums? We can see that these sums are all perfect square numbers. If there's one number, it's 1 squared. If there are two terms added together, it's 2 squared. If it's 3, 3 squared. And if it's 4, 4 squared, and so on. All we have to do in order to solve this expression is that we're going to have to find how many numbers are here, how many terms are in this sequence. And then our answer would be n squared. So how do we find the number of terms in this really long sequence? So how are we going to find the number of terms? So let's see if we can find a pattern again. We have 1 plus 3 plus 5 all the way up to 95, 97, and 99. So we can see that the common difference between each of these terms is 2. And 3, the second number of the sequence, 3 is 1, 2 more than 1, which is a first term. And 5, when n equals 3, it's 2 2's bigger than 1. And when n equals 4, the fourth term, which is 7, 7 is 3 2's greater than 1. So we can write down that the nth term is n minus 1. It's n minus 1 times the common difference more than the first term. So this might be a little confusing. So I'm going to rewrite this in mathematical terms. So the first term in this case, it's 1. 1 plus n minus 1 times the common difference, which is 2, equals, in this case, the last term is 99, equals 99. Because if we only had this part, this expression, we can't do anything to it. We can't solve for n. So we need another side of the equation. Now all we do is solve for n. We're going to minus 1 from both sides to get 98 equals n minus 1 times 2. We're going to divide 2 on both sides to get 49 equals n minus 1 and n equals 50. So are we done yet? Is 50 our answer? No, because we still have to apply the first pattern we found, which is n squared. So 50 squared equals 2,500. And that is our answer. Okay, so now let me give you another example. Let's say we have the sequence 3 plus 8 plus 18 plus 23 plus 28, and so on. And I'm going to ask you, what is the I'm going to make up a number, 29th term? in this sequence. Pause video and see if you can figure this out by yourself first. So we're going to start off with the first term, 3, plus the total number of terms. Let's say that the total number of terms is 29, and then minus 1 from it, times the common difference. In this case, it's 5. To get x, we're going to solve for x. 3 plus 28 times 5 equals x. And 3 plus 140 equals x. So 143 is our 29th term. So the answer is 143.